Sebastian Eskenazi. I work for Pixelz for a while now, not too long though. And so my specialty is computer vision, AI, these kind of things. I've had many lives. That's what my mentor used to say when I did my PhD. Initially, I was an engineer in aeronautics and mechanical engineering, this kind of stuff. So actually, it's funny because I was at the COEX conference a few days ago, and I had people like talking about like PLM, product lifecycle management. Some of you may know that, and CAD, computer-aided design for how you do your products. And well, actually, that speaks to me. And also I was speaking with Kate about like how you do photography and how you've got different wavelength and different color temperatures and so on. And I'm not an arts guy. I haven't done any arts and so on. I'm actually bad at it. But when you talk to me about like 4,000 kelvins and so on, I know what it means because I've got the physics background that explains it. So that's a different side of the fence, basically. But I don't know very much about photo studios. The first time I was in a photo studio was this Monday. So yeah, I've actually learned so much over the past few days since I've been in New York. I'm based in Hanoi, like Thomas said. And I'm still learning. So really, what I'm looking forward to is also a bit of interaction with you today. So if you have questions, even in the middle, it's all right. I mean, I'm really interested in questions and comments. So yeah, go ahead. So I'm going to speak to you about how AI can help creative operations, can help people focus on the hardest task, on the more interesting tasks also. Because honestly, if it's repetitive and not so interesting, like, well, maybe we can handle it, leave it to AI. Yeah. So we're going to talk about 4 topics. The first one will be how AI affects production efficiency. So what's the impact of having an AI in your flow, basically? The second topic will be how do we work with AI? Because you cannot just say, hey, I want to have some AI, someone sells you AI, and then you've got AI and it works. Nah, that doesn't work. Sorry. And the third topic, which to me is really important, is you probably have a lot of vendors that say, hey, I have AI, I'm great, I have great AI. And, well, there's a big hype about that. And so we're going to go over it and see some of the myths about AI. And finally, we'll talk about our success at Pixelz in number, because at Pixelz we do AI, we do real AI, and it really works. So a long time ago, Pixelz didn't have any automation, right? So you would send, and a long time ago, our customers would send us our images in batches. So they would send us like 6,000 images, a big batch, right? And then we would go through it over maybe 10 hours to deliver everything, right? Now we have automation, and it's about 50% automation. So we deliver them in 5 hours instead of 10, and we're quite happy with it. But you know, initial title of this presentation was Our Quest for Better, because we don't stop at 5 hours. We want to do better, and it's like a constant effort from us to improve. And so when we want to go better than 5 hours, at some point there is a limit, you know, because it's not very lean. Some of you who may know about lean, you know that it's better to have a constant workflow, right? A constant workload. And because you deliver in batch, that's definitely not constant. And so what we were thinking about is, hey, what if we could get the images earlier during your shooting day? And so if we split, let's say, 6,000 images in 6 batches of 1,000 images, and then we process them, well, because we process them this fast, the turnaround time becomes 15 minutes. It's not really turnaround time, to be honest. It's more like production lead time, actually, because there are other things around it. There are other customers. There is like time also waiting in the queue in the production. There is the QA. This is just production, but we have QA also to check that it matches your requirements and so on. But it shows a bit like from 5 hours to 15 minutes. That's what it happens. But it's not just about flow, it's a lot about automation. Let's say you do flow, but you don't have automation. What happens? This happens. Basically, you're still delivering images in flow, but the supplier cannot cope. And that's exactly what would happen if we didn't have our automation today. We wouldn't be able to deliver as fast, and the production lead time would still be 5 hours. So that's why automation is such an important part of what we do at Pixelz, because it just takes off some of the load and allows us to be faster. We're talking about time here, right? But time is only part of the equation. You know that usually we talk about triangle, time, cost, and quality. And if we want to compare AI and humans, actually we need to separate quality into two different aspects. One is what I call consistency. Consistency, you probably know a lot about that yourself, is the ability to provide a similar quality across, let's say, a range of shots of the same product. And there is reliability, which is the ability to provide good quality on all the products you have, be it a bag, a shoe, a dress, or whatever. If we look at humans, they're very reliable. I mean, you look at a retoucher, he can do masks for practically anything with a reasonable quality. However, he may not be so fast. They're kind of expensive, humans. And well, you know. And in terms of consistency, they're not so good either. I mean, you can give the same image to 10 retouchers, there's a good chance, you know, they're not going to give you the same output, right? So at Pixelz, the first way we solve this, and that's the inception of the company almost, is we have a virtual assembly line, which we call so. I'll explain more about it in a few slides. And that basically splits all the retouching into some steps, and that helps us improve our speed and our consistency. And that does help. If we look at AI, it's different. They're very fast. Cost-wise, they're quite effective. And in terms of consistency, well, they're perfect, you know? You give 10 times the same image to the same AI, it's always going to give you 10 times the same output. The problem we do have with AI, though, is their reliability. AI may work very well on some images, but very badly on some others. And so we need to account for that. And at Pixelz, basically, we've tried to get the best of both worlds like this. So we keep the humans for their reliability, and we leverage AI for time, cost, and consistency. Now, a little bit about so. So the only way we can have both humans and AI working together is through so. I really couldn't think of a better way to do it myself. So, like I explained, so you have all your retouching process, and it's broken into steps. The advantage here is for humans, it's very standardized, which helps with the consistency. And because one photo retoucher will not do the whole process, he will or she will focus on some core skills that he or she knows how to do really well. And so then it helps really improve the efficiency. For AI, it provides us two advantages, which are absolutely incredible, especially the second one is mind-blowing. So the first one is we have a clear task definition. You know, it's like for a child, basically. You know, you want to teach something to someone, you've got to explain to them what they must do, especially when they know nothing about it. And so if you have a clear task, like we do in so, that's really helpful because, well, you identify the input, the output, the expected quality level, and so on, and you can measure it. And the second part is it's super easy to create a data set. So to train AI, you need a data set, which is like a huge sample, like tens of thousands of images of the input and the output, and then we'll train the AI to learn from this. The problem is, maybe you're not very familiar with it, but creating a data set with the actual quality that we deliver to you, I mean, if we ask people to do it, it's extremely expensive. You know, I mean, you've got to ask them to do all the processing manually, and it's a huge cost, and it takes a huge time to do it. In Pixelz, we do roughly 250,000 steps every day. I want to get 100,000 images for my data set, it takes me a week, and it's free, practically. So, in terms of ability to train AI, I mean, it's just mind-blowing. Now, how do we combine humans and AI? Well, we do this. So I will take the example of the masking step, you know, which is a big part of our operation here. So we have an image that comes in, and we have a first AI that will do a try map, which is like a rough outline of the mask to explain, like, yeah. And a second AI will do the mask. And then the humans come into play. So the first thing we ask them is, how good is the AI result, you know? Some results are really bad, like it's complete failure, and we're not going to use the AI for that, so it goes to the human who starts from 0. In some cases, the result is good, but not really good enough for you yet, for our customers. So we ask humans to work from the AI mask. So they don't start from 0, which allows them to go much faster, but they still are able to fix what's missing. And sometimes it's just perfect and goes straight to QA. And then it continues in the pipeline. You may notice we have 2 AIs. I mean, what's the use? I mean, there's software. Why don't we put it into one, right? Well, you will notice this little feedback loop in the between. And actually, the real point of AI is, yes, why would we use this try map? Well, the real point of the try map is this. Let's say you have this shoe, this image, and now you would like a detail of the bag. Something like this, right? And then we get the mask. So having this try map enables us to clearly explain to the AI what mask we want, what we should focus on. Do you want to keep the prop? Do you want to remove the props? Do you want to keep this part, remove this part, and so on? So for us, this try map is our way of communicating with AI. And you will find that one of the big problems you have is explaining all the variability of the expectations to the AI. That's a big challenge. Just like for humans, you know, communication can be a big problem. It's the same here. Yeah. And for instance, here you see that this bag, like the zigzags, it's black on white and so on. It's kind of tricky, but still works. So yeah, we're quite proud of that. Here is another example where we see, well, it kind of works. So this one, fully automated, I haven't touched it, right? So that's the input image, the output. There was a try map in between, I'm just not showing it. We're very, very proud of our AI because you see the hair, you don't want to work on this, right? Well, the AI does it for you. That's a really good part. It does fail in some places. You'll see here, for instance, it's not fully white, but I mean, that's like a few seconds to fix. This one is, yeah, you're happy with it. Another detail here, look at the shoulder. You know, super low contrast. How do you work on it? Well, the AI handles it too. So, yeah. Same here, white product on white background, and actually we've had worse, still works. So, yeah, really proud. And here again, you can feel the pain. So this one is not perfect. You'll see this is not working very well. But what I wanted to show you here is, well, the mask, for one. But sometimes you don't want a mask, right? Sometimes you want a, yes, indeed, you want a path. And we automate that too. So given any mask, we can make a path like this. And the mask, sometimes it fails. The path doesn't. So assuming the mask is perfect, like as expected, we can get a mask like this. And honestly, it's just like human quality. I mean, so here I want to show you a few details. This is, okay, I'm sorry, it's a zoomed in version, but it's supposed to be curvy, it is curvy. Supposed to be pointy, it's pointy, it's pointy. If you look at the number of path points, actually, that's something where it's not really AI, actually, it's manual algorithm. I coded it myself. There is an optimization algorithm in it, which means that if you want to reduce the path points, it's probably better than humans. An illustration of this is this part, for instance. If you look at the shape of this curve, it's basically a curve, so you've got control points on it. And basically, it's using some very subtle tricks on how you place the control points, how far, and so on. Same thing here. If you look here at the tangent here and the tangent here and all the curve thing, if you want a human to do that, well, it's going to be, I mean, if they're very experienced, it's obviously easier. But so yeah, we're very proud of our AI. We do other things. So pin detection. for some customers. Background cleanup, background extension. So for instance, like if the image is not properly centered and some of the background is missing, we can automate that. We could do a few extra things. We're working on them for some of them. So copywriting, classification of what kind of images it is, texture rendering. It's just an idea of mine, but basically the way I see it is, if you try to buy clothes on a website, rendering the texture of the fabric, I think it's a very big challenge. And well, we haven't really worked on that yet, but I mean, it's always a challenge we can consider. Augmented reality, virtual models, and so on. We have some customers who work with virtual models, so yeah. So talking about AI copywriting. So what we could have, well, my background is really science. I've published in some scientific journals. I've been to scientific conferences. So I've got a quite broad knowledge about what's possible to do. And so we haven't implemented that yet ourselves, but I know it's possible because, well, I've just seen the papers and so on, read them. So you've got washing instructions, and that's pretty easy to translate into something like some metadata. The icons is like straightforward. The text is called optical character recognition, OCR. We can take it off the shelf, or we can develop it ourselves, but it's a pretty mature technology, at least for Latin characters. If you start to use Chinese and so on, it's probably a bit more complicated, but no big deal. And some of the things we can do is, if you have your product image, we can provide tags for it. Like here, it's a necklace with orange, with beads, and maybe amber. Not so sure about the amber part, but why not? And here we have t-shirt, which is white, male, jeans, black. It's torso part, and it's a crew neck. So for some details, we could really customize the tags that are available. I guess we need to think about really with our customers and people interested, like what tags are needed. But it's definitely possible. And you may have heard about in the news recent advances in AI, in a particular field of AI called natural language processing. Allows us to not only take these tags, but actually make a sentence from them. A fully formed sentence, like almost you could put it on a website, although sometimes, like I said, AI can fail. But here we could say an orange necklace with amber beads, or torso of a man wearing a white crew neck t-shirt and black jeans. AI can actually provide this kind of output. It's not like, it's definitely in the realm of possibilities. But again, it can also fail. And here is an example. So from Google, I mean, you know, they're not like a little startup. They call Google. They were a startup a long time ago, but not anymore. And so this is like what they published in 2015. So it's not the most recent research, but it provides a good example. So here you have an image with what's called a herd of elephants walking across a dry grass field. So, and that's actually the image, right? But here it says, this is a refrigerator filled with lots of foods and drinks. Doesn't really look like that. Being an AI guy, I could see why they understand that. But yeah, so keep in mind, AI fails. I'm pretty sure, no matter your use case, it will fail on some images. And so you need to account for that and to prepare for that. So you can leave it to experts like us at Pixelz, and we already have our SO workflow, which is really, I think, one of the best ways to handle it. I had a friend who implemented something similar for the healthcare system in Greece, where they were scanning all the healthcare bills, like $1 million a month or something like that, and with AI. And basically, they still put humans to fix the errors. And you have usually to put humans in the loop, unless you accept the mistakes. Some other failures, well, not really a failure, but let's say, you know, AI, it's not like perfect. This image, it probably hurts your eyes, right? Do you produce these kind of images, like with this beautiful resolution? No, you don't. The thing is, that's the resolution at which AI works. So yeah, it's really like, if you look at a neural network, this is usually the size of the input they take, or the field of view is about that big. So when you have a 40 megapixel image and you want a good mask on it, well, there's a bit of thinking behind the lines to really make it work at this level of resolution. Another challenge is some people will tell you, hey, our AI is super great, and like you can see publications where classification AI, like 94% success rate and so on, accuracy actually. But the thing is, classification, what is it? Classification is a problem where you have a binary output, 0, 1, or true, false. And if you have, let's say, 1,000 classes, then it's 1,000 binary outputs, right? And for words, like natural language processing, it's a lot bigger problems, though. But still, if you take a dictionary, it's like, what, 50,000, 100,000 words? So you just want to know if the words are there. And so you're looking at 50,000, 100,000 binary values, right? An image, it's a bit more than that. We're looking at 40 million, 20 million values. And it's not just 0, 1, it's 0 to 255. So if you were to look at the whole combination stuff, like it's just unimaginable. So again, there is the off-the-shelf AI, and there is what you really need. And what we do, that's why it took us a long time to do it right. Now we have an image like we like it. What is this? Well, this is the output of an AI mask. Could you tell me what is the accuracy? Anyone, give it a shot. What is the accuracy of this AI? Just throw a number. Accuracy, it's in percentage, so between, let's say, 0 and 100%. 50, 90, sorry? 95. Yeah, well, actually, yes. This is 94% accuracy. But no, but you see, that's the problem. How do you speak? Do you speak the same language, you know? 94% accuracy, why? Because it got 94% of the pixels right. So if someone comes to you and say, hey, I've got 94% whatever KPI, it doesn't necessarily mean that they get 94% of the images right. Maybe it's only the pixels. And so when you hear that, you say, wow, I should be able to at least automate 70% of my pipeline. Maybe you automate 0% of your pipeline, but you've got 100% of your images that are 94% right. So yeah, just, you know, be careful. There is a big hype about AI, and yeah, just be careful. So yeah, what we do is our AI can handle between like practically 0.2 megapixels up to 300, almost unlimited megapixels. We do have images this big, 300 megapixels. Right now in one of our data sets, we've got an image that's a bit annoying, but it's 150 megapixels, you know. It's a trailer in a garage. I have no idea why they shot it like that, but they still send us 100 megapixels. And we evaluate our AI performance, so not just per pixel, but also per image. And we have quite a few KPIs. Both averages, but we also have percentiles. So if some of you know a bit about statistics, we do percentiles and so on. And so we evaluate, for instance, the masks. If we look at the transparency difference, so you know it's 0 is fully transparent, 255 is fully opaque. And well, the average error we have is between 4 and 9 on the whole image. So it's an average, so there can be places where it's more and places where it's less. So here is an example of what a transparency error looks like. To give you an idea, 4 or 9 on average is invisible for the human eye. Actually, that's a problem for us because we get some images in our data set where they say, hey, the background's black, and I tell them, no, sorry, it's not black, it's like 11, it's not 0. And, well, yeah, but, you know, after that, you've got some customers who complain, hey, I've got some, like, halo or remaining from the background and so on. I tell them, yeah, I told you. And, yeah. And here is the edge. So, you know, when you have a mask, you don't just care about the transparency, you care about the position of the edge. And so we do measure that. And here you see, for instance, there is like a mistake for the edge. So I've overlaid the mask on the original image for you to see better. But basically here we see part of the edge is missing. So we do check all that. We're working on more KPIs, especially now we're looking at the feathering, like how good is our feather, because that's starting to be an issue also we want to look at. And yeah. So yeah. Now I've shown you like how it can help, how we use it, okay, that's, and I think it's time to ask the hard question, the hard truth, like how much does it work? Give me a number. That's how much it works. 2018, we didn't have our AI in place yet, and it was pure human. Then we start to put the AI in place. So we have like our 3 levels I mentioned, bad, medium, and good. But at the time, it was a start. So we didn't trust the AI enough to put it like without a human checking it. So we had humans checking it, and then humans, and again. And then after a while, we saw, all right, it's really good. And then we start to bypass the humans on the really good images. And so here we have roughly 25% of our images which don't need a human to work on them, for the mask. We're talking about the mask here. But you've got to imagine 25% of your masks are untouched by a human. That's yeah, a start. On this part here, we've got like 60% roughly, where the humans are involved. This part is like pretty quick fixes, and this one takes a bit longer. And the remaining, probably about 20%, is like complete failures. Yes?
Does this mean that there was a small window of time where you were between pure human and mostly human, and that's it? Like where the green? What does that mean?
Yeah, it's you know, visualization issue. No big deal. Sorry about that. Yeah, no, it's mostly like visualization issues. Like the thing is, you see, the transition is so sharp that the tool somehow it doesn't cope up. But yeah, we're really happy about that. And what it means is this. Let's say a customer says, hey, I need to double my images. I want to ramp up by 100%, you know, or maybe it happens to you. Well, for us, what it means is, because we've got 50% automation, that's only equivalent to ramping up by 50%. So compared to if we didn't have automation, that's only plus 50% of the headcount. And only plus 50% for the training of the people and so on. And so that's really huge because it means that we can ramp up or down twice as fast as if we didn't have any automation in place. And these numbers, they're not fake, really. That's the dashboard I look at like maybe once a week to check how things are going. So they're real numbers here. We really achieved, like, the exact number was, I think, 47% last week or month, something like that. But we do have this level of automation. Here is another graph. So again, from 2018, that's for, on average, for our images in seconds, the total production time we spend on them. So all the steps, masking, whatever, retouching, you may want skin, background, color, so on, everything, pathing. So all the production time, it doesn't include the QA time, right? But all the production time we spent on it since the beginning. Thanks to automation, we cut it by 100 seconds every year. Of course, if you look, we're like, I don't remember, but about 300, maybe 350 seconds, I don't know, now. So that's gonna got to stop at some point, right? The time cannot be negative. And of course, the more you automate, the harder it is to automate more. But yeah, that shows that really it helps. Thank you. Any questions?
I mean, can you show some examples, if you have, of all AI? Like the images that were processed, the masks were done all by AI?
Yeah, sure. That's actually, I showed you some of these images here. So this is all AI. This is all AI. This is all AI. On my computer, I have some more, so if you want, I can show you later. But yeah, Thomas?
Yeah, I think that you can show some in the break. So we have lunch break coming up, and
yeah, right.
I think if you can show some examples,
yeah,
that would be great.
Yep.
When you work with a new client, do you ever have to start from the beginning, or start at some sort of previous state of training the AI model for specific specific clients?
So I think, I had this discussion a little bit earlier also. So some people, there are many questions you ask when you train an AI. Should I train it specifically for this customer? Should I train it for all customers? And when we look online, we also see some guys who say, we never use your images for training, but then how does they fit with your problem, right? So for us, we use our AI, it's the same one for all our clients. The interest we see in this is each client has different images, right? And that helps the AI be more generic, and it helps us handle the variability also. And what happens is your trend right now, today, in your market, for your customers, may not be the same as next year. And so that's a problem for AI. It's called drifting. Basically, the fact that your input, the type of input you get, the style of images or whatever, it changes over time. And so if you don't take care of it, well, you're going to end up with AI performing worse over time. And so you wouldn't theoretically need to train it every year or every 6 months or something to keep up with what's happening. But because we have so many varied customers, well, the good thing is it's so varied that the variety stays roughly the same. So that does help us a lot. And now, actually, we still retrain, but not because of the variability, because we want to focus on the points where we're failing right now. So what we do is we train the first time, then we see where it fails, and then we retrain on the failures, and so on. So, yeah.
So there's a infinitesimal percentage of improvement per customer over time.
We could see it like that, yes, definitely. More customers, better AI. Yeah?
So it's safe to say that if you're shooting something on a white background or a blown out white background to be masked out, the AI can handle it. What if we were to like photograph somebody like Allison on location? If she would be on location and take a creative image, but want to bring it into the studio and maybe put it online, would we be able to mask out something with a textured background or a scenic background?
Yeah. So, correct me, Thomas, or the other Thomas, if I'm wrong. But I think at Pixelz we do a lot of e-commerce images. But when I look at the dataset, I also see some images, not so many to be honest, but we do have some images where the background is not uniform. So we do have texture in some. I think if it came to having like more images with a varied background, we would just train a new AI specifically for that case, and then it would work. Actually, in the literature, if you look at it, it does work already, so we would just need to tailor it to our needs. Yes.
You showed an example of the tri-maps where you had done the mask of the individual as a whole, and then you also made the mask of the purse. And my use, the application that would be very useful to me is we shoot whole vehicles in the studio, and it's one thing to create a mask of the whole vehicle, but then my retoucher, there's a lot of creative retouching where he will go in and he'll mask each window, the windshield, the tires, and he'll do extensive local masking with paths. If there was a service that I could just upload a vehicle and it came back with the respective parts as unique paths, that would be invaluable.
It's called Pixelz.
Would it do all the paths for me?
Okay.
Not a whole vehicle, like
I'm not really a salesman, and I was told I pitched too much, so I'm sorry about that. I'm just very enthusiastic. But so we do offer services. It's called Advanced Path and Advanced Mask, where we can mask and path specific parts of an image. So we used to do that for watches, for instance, where you have to put all the dials and every the details. So I don't know much about cars and so on, but from a technical standpoint, why not? After that, it's up to the other guys.
I have a very similar question. Like, for example, with your boots there, can your AI just mask for color, breaking out colors? So if I have 3 stripes on the boots, I could automatically get a path for that, as opposed to like it knowing that there's a tire that you want or whatever else, which it doesn't know what a tire is.
I like very much your question. So I will reply to you with a question. Why would you want to mask by color? Because for me, you see, the real thing is you got someone who comes to you with a question, and then you can just try to answer just the question. But I don't really care about that. What I care is about what is your real need. Let's say I can mask the color. What are you going to do with it? And maybe to each one his expertise, you know what you want to do from a creative side, and I know what I can do from a technical side. And maybe I have a better way of helping you than just masking by the color, you know? So that's my question. You want to mask by the color, why not? All right, but I'm asking why.
Because I mean, we're a shoe company. We make shoes with white soles, with leather, different colors of leather, with other materials. Some of them are very specific colors. Some of the materials, because they're leather, they're different dye lots, they're different. There's, we have to do quite a bit of post-color correction on our product. And so to have the laces, to have the sole, to have the color pods underneath the sole, to have the different materials, or like on a running shoe, there's a lot of color, there's reflective things. There's just for us, for color accuracy is important. And so in post, we do quite a lot of that. And so we want to clip for color generally. Okay, right. So then in that case, definitely masking by color makes sense, of course, if it's for color retouching. Okay. No.
Can you do it? Can you do it?
Actually, all right. Too bad you asked for it. So we do offer color retouching services at Pixelz. So that's one way to solve the problem. Yes, we can do it. Because like I explained for us, so there are actually several ways to do it if you want to identify the colors. It doesn't have to be AI. There are algorithms that specifically identify the colors in the image, and they're able to identify like, oh, you showed me this picture, and in this picture I see this image, this color, in this picture I see this color, this color, this color, and then I can tell you the color is here, and so on. So that's one way to do it. Another way would be with AI, so where, like I explained, we do the try map for the colors, and then we can do the mask. And we can even convert the mask into a path. So yeah. There are several ways to do it. I think it depends on the images, on the result, see what works best for you.
Okay. More questions? Super exciting stuff.
Thank you.